So, here we are now going to talk about multi-period models, that is my expiration date is not at time t equal to 1, maybe at time t equal to 2, time t equal to 3, time t equal to 4 or time t equal to n. So, here we start with a very basic structure when time t is equal to say 3, right. So, 3 period model, how would it look like? Let us draw the diagram. We will get the stock price behavior very soon from here. So, suppose I start with S0, that is time t equal to 0, and then it goes up and goes down with S1 H and S1 T. So, this is US naught DS naught. From here, if I am here, I am on this branch, then I have two possibilities, right. So, which is here S2 H, S2 HH means head, and then in the second toss also is head, and S2 head and the second tail toss is tail. So, these are the two possibilities. So, this will become U square S naught and this will become U d S naught. From here also I will have two possibilities, which will be S1 T H, that is now first tail had come, then head has come, and S1 sorry S2 T H, this index is representing the time. So, this time t equal to 1, this time t equal to 2. So, here tail has fallen, then again tail has come. So, this is nothing but again U d S 0. So, you see this is same, right, and then this is d square S 0. So, these are same, this is equal to these two things. So, now from here again if I am on this branch, I have मतलब from her branch दो बातें होगी, there will be two things which will happen. So, from here I can just take more branches out, but a lot of the values would be similar. So, here what would happen? It will become S3 H H H, and that will be U cube S naught, or it will be S3 H T T, sorry H H T. So, head has fallen, then tail has fallen. So, this will become U square D S naught. Similarly, if you look at this point, you can also make from here two choices, and from here you can make two choices, from here you can make two choices. So, 8 choices in. Now, let us see what is this choice if I am on this branch. So, the two choices are S2 HTH. This is nothing but what happens if I toss 3 coins simultaneously or a coin 3 times. So, these are the outcomes, that is all, S2 HTT. So, if this happens, then from here it goes up. So, it will become U square D S naught, and if it goes down, it will become U D square S naught. So, you see these are equal, sorry not S2, S3, sorry. So, S3 HHT, S3HTH, if the 2H, two heads or two tails, and if the basic structure, not the permutation, but the basic structure is same, you basically have the same outcome, right. So, here again you will have, from here you will have S3 THH, S3 TH T. So, this will again become U square D S0, and this will become U D square S0. So, this was U D S0, U D S0. So, here you go up, so you become multiply by U square D S0, here again, so U D square S0, you see, two tails, one head, they have the same values. Similarly, here you will have S3 TTH, S3 TTT. So, what you will have? Here you will have U D square S0, and when you go down you have DQ S0, U D square S0, U D square S0, U square D S0, U D square S0, U square D S0, U square D S0. So, you see that 3 batches of same value, and these are with the Qs. So, this is the case for time t equal to 3. Now, this is one particular setup. Now, I will draw this with lot more, it will be very difficult to draw, but with lot more periods, and then I will show you a strange and interesting pattern emerges, which we have spoken about the movement of the stock prices in part 1, that they follow some sort of geometric Brownian motion, some sort of zigzag thing comes. So, we will study this here. So, just let me remove all this. I am assuming that this is clear to you. Just as you remove all this, and then I can do the other ones. Here I have done a very bad job, bad picture. So, basically I am trying to increase the number of periods, I am trying to draw the binomial lattice, the binomial diagram. Suppose you come from here, go down there, go down here, then go here, then go here, and if you look at this path, here you have a zigzagging path. Of course, this is a very bad diagram, you can make it much more simpler by having spread outs in a much more simpler way. So, it is always like this, there will be equalities, you have to actually mark up. This sort of thing actually is what happens. So, I could make a much more. So, what you see, you actually have a zigzagging thing coming. So, the stock prices move in a zigzag way can be very well understood by drawing a binomial lattice. Now, how do you do an option pricing in this case? So, here my price or the worth of the option cannot be seen. Suppose I take a 2-period model, right. If I take a 2-period model, after that we will just write the general version of the n-period model. Suppose we take a 2-period model, how do we price the option? How do I get V0 now? I have to first come back to the period 1 and back to period 0. So, now I am taking a 2-period model. In the 2-period model, my worth of my option is V2, which is maximum. So, I am talking only of European call options, nothing else. S2, whatever it is there, and the strike price. This is my worth of these are random variables. I am keeping this, making it look like a function. So, random variable is of course a function. So, here this is my worth of the option at time period 2. So, how now I can be much more straightforward. Now so I have to find V0, the option price. So when you have periods, this, if your expiry time is after say 20 periods or 30 periods or say 100 periods of trading periods, then this binomial lattice gives you a very good approximation of the Black-Scholes price. So V0 is the option price. Now what I will do, so I will invest that V0. So what I have done, so what is my portfolio worth at time t equal to 1? It could be with H or tail, it depends. So I bought delta naught shares of the stock at time t0, sold it at this price, H or T of course, and then the remaining I had invested. I have actually used V0 to buy it, because now I am directly writing V0, I am not writing X0 anymore, because now I know that this is the option price, V0 is X0. So then this is what I get at time t equal to 1, right. Of course, you can write them in H and T form, that is, you could put an H here and you could put a T here also. Because V0, delta naught, S naught, these are fixed quantities, so you do not have to bother about that. Now this is the worth of my portfolio, this is the money I get by trading in the portfolio at time t equal to 1. Then at time for time t equal to 2, I buy delta 1 amount of shares. I buy delta, so delta naught share is bought at time t equal to 0. So I had delta naught shares is bought at time t equal to 0. At time t equal to 1, we buy delta 1, that is the guy who has sold the option and then is using the option price to trade in the market, will buy delta 1 shares of the stock. So at time t equal to 2, what is the value of its portfolio? So time t equal to 2, the value of its portfolio is x2, and x2 can have many options. X2 can have HH, it can have HT, it can have TH, it can have TT, right. So value of the stock should be this delta 1 S2, this is the amount I can sell, delta 1 S2, this is the amount I can sell, and I had x1 amount of money at time t equal to 1. With that I have bought delta 1 shares of stock and remaining I have put in the money market. So from where I will get x1 minus delta 1 so delta 1 was bought with S1 amount of money, could be H or tail, that does not matter, and so and then when I come to time 2 I sell that delta 1 shares, and then this is the money I get from the money market. So this is my total wealth. So this is written as a random variable. Now we will put this T, T, TH and all those things. Now what I will do, I will write down what are the 4 possible cases with the x2. So I am just now rubbing everything and I am now writing down what are the 4 possible cases with x2, and we will use the same P tilde and Q tilde, the same risk neutral probability which we have got with the data of the problem to solve this problem also. Because our data is nothing but U, R and D, nothing else, that is the main data and S naught. So this is the same writing, but I am just writing it down. Now delta 1, this share is also depends on what head and tail has come. The delta 1 share that you get, so we have, so x2, now if 2 is the final period, x2 must be same as the worth of the option. That is the whole thing. So, instead of writing this, I just write V2 HH x2. So, the delta 1 share, that the amount you buy will depend on what is the outcome of the coin toss at time t equal to 1. You cannot just fix up something. So, that is also a random variable. Delta itself is a random variable. You see how uncertainty has entered into the picture without you realizing it possibly, because it looks very simple, but you are actually in an uncertain zone, and so it is pretty complicated stuff actually. So, how do I write this one? So, it is delta 1 H. So, if I have H's come in the first one, and I got delta 1 H S2 HH plus 1 plus R x1 H, because x1 is what I have in the worth of my portfolio when H has occurred in the first step. First step H has occurred. So, minus delta 1 H into S1 H. Similarly, you can write V2 HT is x2 HT is delta 1 H into S2 HT plus 1 plus R x1 H minus delta 1 H S1 H. So, S1, the first outcome was head. Now, again the first outcome was tail, and the second outcome is H. So, it will become delta 1 T into S2 TH plus, they are same, but does not matter. So, this is different from this. 1 plus R x1 T minus delta 1 T into S1 T. The same story will come, it will be x2 TT is delta 1 T S2 TT plus 1 plus R x1 T minus delta 1 T S1 T. So, essentially we have 6 equations, because we have the equations for x1 H and x2 H, the x1 T, the worth of the portfolio at time. So, 4 equations and 6 equations. The worth of the portfolio at time is delta naught S1 H plus 1 plus R into V naught minus delta naught S naught, delta naught S1 T plus 1 plus R V naught minus delta naught S naught. So, you have 6 equations. And what do you have to find? And you find your unknowns. What are your unknowns? V0 is your unknown, right? V1 is your unknown. V0 is your unknown. So, V0 is your unknown, delta naught is your unknown. Then you have to find, so let us write down the unknowns. So, you have 6 equations, how many unknowns are there? So, my unknowns here which I have to figure out is V naught, I have to figure out delta naught, I have to figure out delta 1 H, I have to figure out delta 1 T. So, the unknowns are V1, delta naught, delta 1 H, delta 1 T, this is I have to know. And I have to also know what is my worth of my portfolio at at time 1. So, there are 6 unknowns in 6 equations. See, these are already known to me. This V2 is known, but because V2 is equal to x2, x2 is actually known. This is not unknown. So, now how will you go about solving it? So, again I would not go into the detail, but just write down the results of this by using the same risk neutral probability. So, use the same P tilde and Q tilde, the same risk neutral probability. So, once you take the with the P tilde U tilde given by the same formula that we have done in the last lecture, right. So, now we will rub this part, and I am assuming that you have already taken it down, and then we can just solve it. So, I give you the solution, because it is no use for me going through the algebra and wasting the time. You can do the algebra yourself, rather giving the solution directly to you. I want to tell you that delta naught would be same as what we have done earlier. V naught of course will take its different form, but let me first write down the case of delta 1 t. So, the delta hedging at time 1, how much stock you have to buy. So, delta 1 at time t is V2 TH minus V2 TT. So, if the first, if the outcome is T in the first, and the second outcome could be H and outcome could be T. So, V2 H, and this is the same one H2 TH minus the same story, just writing it in a slightly complicated way. And X1T, X1T you can write the H form, I am writing the T form, you can write put a H here. If I put H here, it will become HT, HH minus HT, HH, HT, that's the thing. So, X1T, it is, I will tell you what is happening, here it is 1 by 1 plus R, it is again the expectation in terms of the risk neutral probability, P tilde V2 TH plus Q tilde V2 TT, because V2 and X2 are same, and this is exactly equal to your V1T, that is the worth of the option at time t equal to 1. Right. So, V1T is exactly equal to this, because worth of the option at time t must be the same as my portfolio, then only I am doing a perfect hedging. So, I am not writing the delta 1 hedge, delta 2 hedge and all those things. So, you can just write down, you just changing the things. Now, I will write down the case for a for nth, if there are capital N, say I have period starting with 0th period 1, 2, these are the periods. So, the expiry time of my contract is N. So, you can exercise the option only at time t equal to N, and then what is the price of that option is what we are going to calculate now. So, now we are going to write the general formula for replication in the multi-period model. I am not going to prove this because it is the same sort of repetition, only you increase the number of periods. So, I am just writing the result. So, replication in the multi-period model. So, there are, so we have n period binomial model. So, we consider n period binomial model. So, if you want me to write down everything in detail, consider a n period binomial model with 0 less than d less than 1 plus r strictly less than u, which is a no arbitrage condition. Fine. And of course, consider the risk neutral probabilities. Let P tilde and Q tilde, the risk neutral probabilities, as given as 1 plus R minus D by U minus D, and Q tilde is given as U minus 1 plus R or U minus 1 minus R, does not matter, U minus D. So, this is there. So, let Vn be the payoff, Vn be the payoff of the option at time t is equal to n. So, it has to follow, you know, t equal to n means, thus there is a path by which we have written V1, omega 1, omega 2, omega n. So, this could be head, tail, tail, head, like this. It could be head, tail, head, right. So, basically you will start with Vn, you know Vn would be equal to Xn, capital Xn, the worth of your portfolio time n, go to Vn minus 1, Vn minus 2, and recursively go down to V0. This is exactly the way dynamic programming is done. You are going recursively back to V0, right. So, once you do that, what would happen? Then for a general n, then for any n we have that Vn, that is the worth of the option at time n, is the expectation of, or a expectation on a risk neutral probability of its values at time n plus 1. So, suppose I want to know Vn with the outcome omega 1, omega 2 dot dot omega n. These are my outcome. You may not give commas also, I am just giving commas, it is the way I write it. So, you can just give omega 1, omega 2, omega n. This is nothing but a discounted price P tilde V n plus 1. So, omega 1, omega 2, omega n has occurred up to n, then at either head can occur or tail can occur. So, this is exactly the price, it is exactly the, it is nothing but expectation of Vn plus 1 given. So, if I know the information up to n, so it is the, so omega 1, omega 1, omega 2, omega n is in the filtration Fn of the sigma algebra, if you want to write it like that. Then this is nothing but the conditional expectation, if you have learned conditional expectation, and that is what we will talk about in the next talk. So, what it says, the worth of the option is nothing but the discounted value of the conditional expectation of Vn plus 1, and obviously the Vn, this random variable, is nothing but 1 by 1 plus r of the conditional expectation under the risk neutral probabilities. So, this is the way you compute Vn. Delta n is computed in a very similar way. So, if you know this has occurred, then this is nothing. You will just have to write Vn plus 1 omega 1 omega 2 omega n h minus V n plus 1 omega 1 omega 2 omega n tail divided by Sn plus 1 omega 1 omega n h minus Sn plus 1 omega 1 omega n t. This is what you are going to get. Now, of course, at the end you have this fact that xn omega 1 omega n, it must be same as Vn omega 1 omega 2 omega n. So, this is the general formula. So, once you know this fact, you just put the fact reversibly and go back to V0. This looks very easy when you write down the theory, but not easy to compute actually. But of course, you can do it, there are ways to do it. But there is no time to really discuss about those things, and you need a full semester course that has to be given for all such discussions. And there is nowadays a lot of way of doing finance. Finance has moved beyond Black-Scholes. So there is a lot of issues in the incomplete market that, for example, you have in the indifference pricing, all those things, and largely things are done in the incomplete market, and you can look in terms of utility functions and all those things. A lot of issues have come, a lot of economic issues have come, statistical issues have come. So here we are trying to get you into the basics of mathematical finance. So those who, for example, work in optimization and say finance as an application, they should remember math finance is a much bigger area than math programming, and they should also realize that what we are trying to do here is just trying to put a light in the entrance of a huge hall called the Hall of Mathematical Finance. So with this we will go on to the next thing. We will show how this risk neutral, all these things what we have just written down is done, what are the nature of stock prices, is it a martingale or not, what are the nature of the wealth. So we will talk about wealth equations and all those things. So at x, when you will write xn, we will call that the portfolio value at time n is called the wealth equation when you write the equation down. So all these things we will discuss in the next one, which will be our discussion in the binomial model, which will be the last discussion of the binomial model. Next week we will discuss this whole thing that we have discussed here in continuous time, and so that we will be able to finally compute the Black-Scholes price. So Black-Scholes price is going to be just the beginning of your study in finance. Please remember, somebody who wants to have some knowledge in finance has a huge pressure on him, because he needs to know a lot of important aspects of mathematics. It starts with linear algebra, optimization, probability theory, stochastic process, differential equations, and so one can get into the model of Bessel functions and everything, and into classical analysis and classical differential equations. Things can, on special functions, things can get bit messy. So one really has to focus on particular area of mathematical finance if he wants to do anything. I just want to say that mathematical finance is indeed extremely huge subject. Trying to understand each and every aspect of it might just backfire. So one should focus and then just learn one part very well. Portfolio optimization, focus on portfolio optimization. There is risk management. Option pricing, focus on option pricing. Statistical tools, focus on statistical tools, and something like that. Capital CAPM, focus on CAPM, something of that sort. Thank you very much.